Hi, my name is Mike Coleman. I'm a developer advocate on the Lightsail team at Amazon Web Services, and today I'm going to take you through a little bit about how you can use Amazon Lightsail's monitoring and alerting features to help you monitor and then resolve performance issues on your systems. So we're going to go through and we're going to talk about, like, real quickly, what is Lightsail to make sure everybody understands what the service is. Then we'll actually go in and we'll look at that monitoring, alerting, and notification system in a little more detail. Do a demo on how you set alerts and notifications. We're going to spend quite a bit of time on explaining how burst capacity works, because it's a common source of confusion and can lead to some pretty significant system performance issues. And then we're going to actually look at how you can resolve those issues. I'm going to take you through a mock scenario, fairly basic, fairly rudimentary, but one that will hit on some of the high points of what you need to understand if you're going to look at how to resolve some of the CPU performance stuff that happens with burst capacity. And then we're going to go ahead, and then I'll close with one slide on, but what if you need to do more than what we talked about today, and how you can look at that. So just level setting, this is not an in-depth examination of system performance and how you monitor and resolve. And this is a vastly complex topic. This is a 101, probably 200 level examination of, intended for people like you've got some cloud instances deployed. You understand the cloud, but you haven't done a lot with system design. You haven't done a lot with monitoring and alerting. And so you want to learn some of those basic principles. So how do I get started? How do I look at CPU databases, load balancers? How do I look at a system holistically and kind of, take those first steps at understanding how the system's performing, and then working to help resolve those issues when you run into them. So what is Amazon Lightsail? So the way I talk about it is it's AWS made easy, the cloud made easy. When you're first learning AWS, there's a lot of concepts out there, things like virtual private cloud or VPCs, and what type of storage do I choose, and what type of instance sizes do I choose. And navigating through all that as a brand new user, especially if you're brand new to the idea of the cloud or virtualized infrastructure, can be overwhelming for some folks. And so the first thing we wanted to do with Lightsail is take some of those choices and make them for you. So we're an opinionated service. We've picked a way to set up the VPC. We picked which type of storage. It's always SSD, for instance. We have a limited number of instance sizes that you can choose from. And all of those things make it easy to just jump right in and get started, right? You can deploy a server literally in one click. The other thing that people often get confused with or struggle with when they come to AWS is understanding how to compute the prices that they're going to pay. We do this pay-as-you-go pricing, which is wonderful because you're not paying for services that you're not consuming when you're not using them, right? So if you only you want to experiment with machine learning, you can fire up a SageMaker instance and you can play with machine learning there for an hour or two, and you can shut it down and you only get charged for that hour or two, as opposed to having to go out and buy a whole server, right? And install it and rack it and power and air conditioning and all of that stuff. And only to realize you don't really need it, right? Or it's too small or it's too big. So with the cloud, the ability to pay as you go is amazing, but it does require you to be able to kind of look at something and say, okay, well, I'm going to pay for my instance. I'm going to pay for my storage. I'm going to pay, my network throughput. So what we've done to help smooth that out for people is we give you the price up front. And we say, look, if you run this instance for a month, you'll pay $3.50. And that's our lowest price instance. But if you only run it for a day, you'll pay 1/30 of that. So you'll pay like a dime or a little more than a dime, right? And so you still get the benefits of the pay-as-you-go pricing, but you have the upfront cost laid out in front of you for the entire cost of your server. And that makes it really nice for people when they look at it. They go, okay, well, if I put my website on this instance, it'll never cost me more than $10 a month, or it'll never cost me more than $3.50 a month. The only exception to that, as far as instances go, that you should be aware of is we do have a data transfer limit. It starts out at 1 terabyte a month. It's a lot of data, but if you were to go over it, you would incur data charges. Most people will never come anywhere near that. And then there's another one with instances. If you assign a static IP to your instance and then delete the instance, the static IP is not deleted and you get charged for it. Static IPs are free as long as they're attached to an instance. But other than that, it's super simple to look at something and say, well, it's going to cost me $40 a month to run my highly available WordPress website. We also wanted to make it easier to move through Lightsail, to use the console. So we have our own console, different than the AWS console, designed to be intuitive. We're in regions across the globe, so we do have footprint across the globe, and we just want to make it easy again to get started. So the console is one way of doing that. But if you're like me and you like a command line interface, or if you're writing applications, you want to use an application programming interface to set up your infrastructure, all that is supported as well, right? So you have the easy to get started console, but you also have the full power of the CLI and the API behind it. And then the most important thing is you can go get a cheap virtual server from a bunch of different vendors, right? An inexpensive virtual server from a bunch of different vendors, but none of them are AWS. And so we run some of the largest websites in the world on AWS, and that's the same infrastructure that your website's going to run on. And if you decide that you wanted to explore machine learning or integrate machine learning into your application, you can do that. Lightsail can consume all of those other AWS services, well, or most of them, not all of them, but most of them. And that's something that other vendors don't offer. So if you go set up an instance on a popular VPS provider, and you say, well, I need a message queue. Well, you're going to have to install something like RabbitMQ and manage it yourself, right? With AWS, you can just use our message queuing services and all of that other stuff to expand your application. And if you decide at some point that you'd rather be on EC2, which is the cloud instances on AWS, then you can just migrate from Lightsail into EC2, and then you can use things like auto scaling, which we don't have on Lightsail. So you can consume AWS services as you need to expand the portfolio of capabilities of your application. And you can ultimately just migrate everything into AWS if you need to, at the end of the day. And people say, well, how do I know that I don't want to be on Lightsail? How do I know when I should use Lightsail or EC2? My recommendation is you use Lightsail until you can't. You use Lightsail till you realize, oh, my database, I need some read replicas. I have too many reads coming in and I can't scale the database correctly using the Lightsail databases. So I'm going to use RDS. Or, I want to run a large in-memory database. I want to do something like Redis. I want to have a large memory cache with Redis or Elastic or whatever. So you can run that on a memory optimized EC2 instance if you don't want to use the managed service, right? So if you need a specialized instance, if you need to have advanced database capabilities, those are all reasons to move into full AWS. So that's what Lightsail is. We built it to make it easier to get started, easier to run, and more predictable pricing. A feature that we recently added that's been really popular, it's gotten pretty rapid adoption. It's a free feature. There's no additional cost. It's the last bullet, but it's probably the most important point to some folks. There's no additional cost for this service. And that is basically Lightsail Monitoring. And what monitoring allows you to do is it allows you to pick various metrics on your instances, your databases, your load balancers, and track those over time. So we collect those metrics on 5-minute intervals. So you'll get an updated metric every 5 minutes, and we'll retain them for up to 2 weeks. So when you look at the graph, and we will look at one here shortly, you'll see that as you go through, you can be, I want to look for the last hour, I want to last for the last 6 hours, the last day, the last up to 2 weeks, right? I think it's week and 2 weeks behind that. So we'll hold that data for 2 weeks. It's a rolling window. The other thing it was really important when we made this service was we wanted to give you reasonable default values to start with. So, and this kind of goes into the alarming part, but we wanted you to be able to go in and say, well, if I'm going to look at the CPU, where should I start? What's a good value to set my alarms on? So we added that in there, some what we believe are reasonable defaults that you can, of course, change if they don't work for you. And the metrics you can measure differ by whatever resource you're looking at. So when you're looking at instances, how much CPU utilization do I have? How much burst capacity do I have left? And I'm not going to talk about burst capacity because I have like 4 slides on it coming up. How much traffic is coming in and out of my instance? Am I seeing big, huge traffic spikes? Do I need to find ways to accommodate those? Do I need to Maybe what I need is to hook up CloudFront to take some of the network traffic and redirect it to caches closer to my customer. We have a couple different types of status checks that we do, instance and system. And if there's a failure, we can report that back as a metric as well. There's another metric that I don't have on here, which is when both instance and status check, system status checks fail, right? So if you want to look at one or the other, you can. But if you'd like to look at both of them, you can just set this one metric rather than having to set two. On the database side, CPU utilization. Again, how much CPU is my database consuming on the instance? How many connections simultaneously to the database at any given time? Queue depth is the number of requests being read or written to the disk. So you don't want to have that. If you have a queue depth that's expanding, that means your database is not processing the requests quickly enough and they're being made to wait, which is not a good state to be in. A little bit is fine, but you want to monitor that and you want to look for excessive queue depth. Free storage space, how much disk do I have left on, space I left on my disk? Pretty straightforward there. And again, network throughput. And then our load balancers, you can enable SSL on the load balancer. So TLS negotiation tells you when that setting up that secured connection has failed. We can report back from the instances behind the load balancer, your actual web server, 200, 300, 400, and 500 status codes. So HTML status code responses. So 200 is generally regarded as everything is okay. 300 is typically a redirect type of operation. 400 is insufficient permissions or something wasn't found. And then 500 is a internal server error. Typically it's something that falls out of those other areas for the most part. The load balancer also has its own set of status codes. 400 and 500 only, though. We can't redirect off our load balancer, and the load balancer doesn't really send the 200 responses. Those come from the actual application running on the instance. Real important one, healthy, unhealthy host count. So if you set up a load balancer in front of 5 instances, you probably want to be notified if one of those goes offline, and the way you do that is through healthy, unhealthy host count. So if my number of load balancers is less than 5, let me know, right? So that's a metric you can check. Connections that we've rejected, if you're dropping connections, why is that happening? Well, first, before you can even ask the question, you have to know what's happening. So you set up a metric on that, and then request count is just the number of connections into the load balancer at any given time. So coupled with monitoring is alerting and notifications, and these are pretty simple concepts. So I only have one slide for the both, but it's basically, and I have a demo, right? And so the demo will show you exactly what I'm talking about. But you can define up to 2 alerts per metric. So you can have a warning level and a critical level. And again, these are up to 5-minute granularity, right? So, or excuse me, not up to, it is 5-minute granularity. I was kind of munging two bullets together. 5-minute granularity means that we're only going to get that metric once every 5 minutes. And these alerts they're defined as X occurrences in Y time. So what does that mean? If my CPU goes over 20% twice in an hour or twice in 30 minutes. So let's say the CPU, it's actually periods of 5-minute periods. So for more than 2 5-minute periods within 30 minutes, alert me. So if the CPU goes to 25% and it sits there for 5 minutes, then it drops to 15%, then it goes back to 25%, we will alert you because that happened twice in the 30-minute period. Or if it goes to 25% and is there for 10 minutes, that's 2 5-minute periods. So twice in 30 minutes, we'll alert you. Again, data is retained for 2 weeks, and that duration period that we talked about is up to 24 hours. So you could say if the CPU goes over 60%, 10 times in 24 hours, let me know. So if it spends more than 50 cumulative minutes over 24 hours, let me know. And then let me know is done via the notification. So you're always going to get a banner in the console that's going to pop up if an alert fires. So if an alert is fired, if an alert goes off, then we're going to put a banner in the console. But we're also going to give you the option to be emailed and receive a text message. And those text messages are subject to certain regions. We don't have the capability to send text in every AWS region, so you'll want to check the documentation on which regions are restricted. But that's it, right? So an alert goes off, you'll get an email in your inbox, and then you'll see a console banner, and you may get a text message. So let's go ahead and take a look at a demo of that technology in action. Okay, so this is the Lightsail console, Lightsail homepage, and I just wanted to stop here a second. And if you haven't seen it before, I wanted to point out, so you can tell just by looking at it, it's really different than the AWS console. And here on this console, I have a bunch of instances I created. So I'm just going to go ahead and scroll down here and click on one of them, and then we'll set the alarms for it. So we'll come down here. I'm going to click on the metrics item up here on this horizontal menu. And I want to pause here for a second. Something we're going to look at a little bit later is this idea of burst capacity, but I want to point something out in the graph real quick. You'll notice the upper part of the graph is sort of a light orange color. That is what's called the burstable zone, and then down below is the sustainable zone. And I'll talk about those things in a second, but I wanted you to see the graph and notice those differences. Just put that in the back of your mind for later. Okay, let's scroll down and create an alarm. So we'll do one on CPU utilization, and we'll click Add Alarm. And, I can look at all the different sort of ways of looking at two data points, greater than, less than, equal to. Because this is a demo, we're just going to do one data point in 5 minutes. Notice we could do hours or minutes. Again, for the demo, one time in 5 minutes. Let's go ahead and add an email address. So I'll paste in one here. Add contact. It's going to warn me that I need to verify that email address, so we will do that. And then I'm going to come in and put in a phone number as well for a text message. 555-1212, obviously not a real phone number. And we'll click Add Contact. So that alarm has been set. Once in 5 minutes, over 20%, send me an alarm. Let's create a second alarm. Just so I can show you how this show up on the graph. And we're just going to add alarm, and we'll do 99%, right? So just change that, and we'll click Create. And now if you look at the graph, you've got two horizontal levels there where you can actually see how the alarms are represented on the graph. So in my inbox, I've got the request to verify my email. So when you set up the alarm and you say, hey, send me an email, one of the things you have to do is you have to verify your email address, and that's what this is. So we'll click on AWS notification, and we'll come in and we'll say, verify my email address. So that's done. Now, the email address and the text phone number are stored under your account settings. So if I come over here and I click on account and I click on account again and I scroll down, there you can see the email address that I had set up for previously. So that's where they're stored. So let's go back to the home page and see if our banner has fired up for the alarm, and it has. So there's that console banner telling me my alarm has been exceeded. So if I click on my email, I have an email notification as well. So here's the email notification, and it tells me, what the alarm was, what instance, what was the threshold, and all of that stuff. So that is Lightsail notification and alarms. Real quick walkthrough. In the previous demo, I mentioned real briefly this sustainable zone and burstable zone. Showed you that on the graph, and so let's talk about that. So a burstable instance, right? What is a burstable instance? Well, Lightsail offers burstable instances. It's the class of instance that we use on the service, and burstable instances are designed to give you the CPU performance you need, sort of at a balancing price and performance. So if you think about a site like, let's say, a fantasy football site, during the week, there's not a lot of activity. People are maybe doing a couple trades. They may have to do, set their roster, but the CPU is pretty low limit, pretty limited in what it needs to do. There's not a lot of simultaneous connections because there's just not a lot happening. But on Sunday, when the games are going on, or when the games end, people are all logging in. They all want to check their scores. So on Sunday, there's this huge burst of traffic that is much higher than what you would have during the week. In a typical server that doesn't use a burstable instance, you would have to buy a server that had the CPU capacity to handle Sunday. So you would, in essence, be paying for a server And the vast majority of the time, your server is over provisioned. You don't need all that extra capacity because you're not using it. So what we do with burstable instances is we say you're gonna get a server that has a baseline of performance, right? So in the instances we're gonna look at today, it's 20%. So as long as your CPU is under 20%, that's great. It acts just like any other server that you would use. However, when that spike hits, you can burst up into that burstable zone and handle that traffic spike. And the time you can spend in the burstable zone is based on something called burst capacity. So the burst capacity is what lets you handle CPU spikes. The burstable zone is where you travel, right? And then when you're in the burstable zone, you're consuming burstable capacity. And the amount of capacity you have and the length you can stay in the zone is a function of the instance size. So bigger instances have more burst capacity, and how far into the burstable zone you are. So let's drill down on that a little bit. So burstable capacity is measured in burst capacity minutes. And a burst capacity minute is 1 minute of the CPU at 100% utilization. So if you pegged your CPU at 100% and you ran there for 5 minutes, that would be 5 burst capacity minutes, right? But if you ran there for 4 minutes at 50%, it would only 2 minutes of capacity, right? So 50% of 4 is 2, obviously. And then 10 minutes at 25% would be 2.5 minutes of capacity. There is, as I mentioned, a maximum capacity you can hold, and you can't earn more than that. So the most you can ever have in reserve is dependent, it varies by instance size. So it could be 75 minutes on one instance. It could be 288 minutes on another instance, depending on the size of the instance. And then by the same time, there's a recuperation rate. There's how fast do you earn CPU credits? So you're always earning credits. You're constantly earning them up to the maximum. So while you're draining credits, if you're bursting, you're also earning credits. The rate of earning credits, again varies. So it may be 12 on one instance, and it may be 30 or 40 per hour on another instance. Think of it like a bucket. You have a hole in the bottom of your bucket, and the size of the hole is how fast your CPU is running, how much CPU utilization you have at the time. And then you have a hose filling it back up. The hose is that sort of recuperation rate, or the rate at which you earn you replenish your capacity. I think replenishment's a better word. So you're replenishing your capacity at a fixed rate up to a maximum. And the maximum is how much water does the bucket hold. So long as you are draining slower than you are filling, you're never going to have a problem. If you are draining faster than you're filling, your bucket will eventually run out of capacity. And how long that takes is, dependent on how far into the burstable zone you are. And we'll look at that on the next slide. The gist is you want to pick a server size that you can burst into it, but you're not in a state where you're bursting more than you're recovering on average, right? If you're bursting more than you're recovering, you're eventually going to run out of CPU capacity, burst capacity. And what's going to happen is the CPU is going to throttle, and you're going to basically, your site's going to slow way, way down. And that is a very common issue that we see customers run into as it relates to burst capacity. So we'll get reports on the forum from time to time of people saying, hey, my system just locked up, or my system's really slow. I can't SSH, or it seems to have shut down. That is almost always a case where the customer has run out of burst capacity. And I don't blame them. Like me personally, when I look at an array of prices, and one is $3.50 and one is $160, and there's a range between there, of course, 5, 10, 20, 40, and 80. But I'm going to pick the one that's the least expensive that I think I can get away with. And prior to this new feature release that we just released, there was no way for you to know, even if you were in the burstable zone, let alone how long you could operate there. So people were kind of flying a little blind with that regard of being able to figure out, am I overtaxing my CPU? This feature here is designed to help people not run into that situation where you are, you're running out of burstable capacity and your system is throttling. So some burst capacity math. Let's say we have a server that has a maximum burst capacity in minutes of 288 minutes. That same server has a replenishment rate at 12 capacity minutes per hour, right? So every hour you're earning 12 credits up to 288. If you were to burst that CPU at 100%, it would take you about 6 hours to exhaust all your credits. That is basically at 100% CPU for an hour, you're consuming 48 burst minutes because you're using 60, but you're earning 12, so that's 48. And with 288 total minutes of capacity available, if you're draining it at 48 minutes per hour, it's going to take you about 6 hours to completely drain your CPU, and you're going to go into that throttled state, which is not anything you ever want to happen, especially on a production site. At 50% CPU, using that same math, you're consuming 30, you're replenishing 12, which is a net of 18. 18 into 288 gives you 16 hours per day at 50% CPU, right? So let me show you a graph on that so you can kind of see how those things interrelate. So here is a graph of a system where I put some load on it so you can kind of see how things work out. So you can see we start up here in the burstable zone, and as you notice right here, we start to lose capacity. But then we drop and we operate for a period of time here in the sustainable zone, so we actually start to grow capacity back because we're growing it, we're earning it faster than we're spending it. You never spend capacity when you're in the sustainable zone. And while we're in the sustainable zone here, basically during this whole period, right, we start earning a bunch of credit. So the credits start to earn, we're doing good, and then we hit this spike here and we lose a bunch. So this spike right here is where you kind of see this big drop off because we're operating at near 80%, kind of operate down here under the zone, spike up a little bit again, drop down again. So spike and drop, and then we spike again and we start to lose credit. So your credit depletion is directly the inverse of the CPU capacity, right? So as long as you're below the sustainable zone, you're earning credits. And if you're operating above it, you're losing credits. So that's how those things are interrelated. And in the next section, I'm going to go through and we're going to look at, well, what do I do if I look at my server and find that I have been spending too much time in the burstable zone and I'm headed for a problem? So what do you do? So the first thing you have to do is you have to decide, you have to know what is a normal operating pattern. So in my example of the fantasy football site, I know that a normal operating pattern for me is that Monday through Saturday, right, my CPU should always operate in the sustainable zone for the vast majority of the time. There may be the occasional spike where people, just randomly people jump in and there are random spikes. So it just happens that on Wednesday lunch hour, that's when everybody decided to set their lineup and my CPU spiked for an hour. Well, the burstable instance can totally handle that. And I also know that on Sunday, I'm going to spend a lot of time in the burstable zone, but I know I'm not going to spend so much time that I'm going to exhaust all my burst capacity. Right? So that's, you have to know what a normal operating pattern is. If you don't know what a normal operating pattern is, you don't know when you have an anomaly. So the first thing is you have to set up your monitoring. You have to kind of run your monitoring for a week or two and look at the graphs and figure out what's going on, right? This is assuming that you're not already in trouble, right? If you're already in trouble, you'll need to just sort of kind of guesstimate at what you need. But with this method, you can have a little more insight. So you also need to track changes over time. So your normal operating pattern may change. If you're running a WordPress site and you install a new plugin and that plugin isn't well written, it may increase the CPU utilization of your WordPress site, right? And so your new normal might be that instead of a sort of a ongoing CPU utilization of 14%, the new normal is 18%, right? So you need to know that. You may update your web app. You may be running a Node application. You may add some new functionality, and maybe you introduced a bug in the code that created a race condition. And so all of a sudden you're seeing these random CPU spikes. Well, unless you kind of track the changes to your site, you're not gonna be able to correlate those things and say, you know what, I think what happened is it's this code change. Like we did this change on the 15th, and from that day on, we've been seeing these problematic spikes. And when you find those anomalies, investigate them. So we'll look at an example where it's web traffic, but what you need to do is you need to go in and you need to use tools like top or htop or something to go in and start looking at the CPU processes. So those tools can show you what is running, when it's running, what's consuming CPU, how long it's been doing that, what's the average load over time. They're a good complement because you can see the CPU performance on the Lightsail graph. Those tools like top will show you what's actually driving that CPU performance. Unfortunately, with something like top, you kind of need to like pull it up when you see a spike. So it's kind of a real-time tool. There are other tools that are not. That's an advanced topic. As we said at the beginning, this is sort of a getting started. So once you have those, you know what the new normal looks like. You have to find a way to model that. And so I would look at, I'm going to use a tool called Apache Benchmark. An Apache Benchmark can put web load on a web app. So in our case, we're going to be using a simple PHP application with a backend database. Oh, and that's the other thing I would say is like investigate also includes looking at the other components of your system. So in my case, I have a web app and a database. I should make sure the problem isn't my database. If someone says, oh, it's slow performance and I'm seeing CPU spikes, but it could be the database, right? They could be related in some way. So check out the other pieces of the system, right? Both the web app, the web servers in this case, and the database. So we're going to go in and we're going to look at the database, but I know what's happening. It's web load. And so I can figure out what's the average load on my site. I can use Apache Benchmark to recreate that load with other configurations to see how I might choose what the right type of scaling is. And we're going to look at vertical scaling and we're going to look at horizontal scaling to deal with a performance issue. One last thing before we get there, be aware of the AWS stress testing policy. That is a policy that we have in place to prevent people from hammering machines and causing system problems. Everything we're doing here falls well within the realm of the policy, but you should be aware of the policy. You should read the policy so to make sure that you don't run afoul of it at a different point. So with that, let's jump into a few demos on how I'm going to remediate the system performance issue. So let's start by looking at how this application is structured right now. So the application is it's a two-tier application. It has a web front end and a managed MySQL database on the back end. That's Lightsail's managing that database. The machine itself has one vCPU in the machine. So we're going to look now, and remember this machine's having performance problems. We'll look at the performance graph here when I start the demo. But this is where we're starting, and we're trying to figure out how we can get the CPU utilization into a manageable state. Okay, so here is the server in question, the one that's giving us trouble. And what we're seeing here is that it's spending a lot of time in the burstable zone. Sure, it drops out of it, runs kind of right at the edge for a while, and it always ends up back in that burstable zone. And as you can see, the credits are going down over time. And so eventually it's going to run out of credits. So the first thing is, what's causing this problem, right? Well, this is a two-tier app, and we're just looking at the CPU. So we could go in and we could look at the database. So let's go ahead in here, databases. We'll come down, we'll click on it. And if we look at the metrics here, so CPU utilization on the database looks good. If we come in and we look at the number of connections to the database simultaneously, never more than 10 or 11 connections at a time. So that doesn't seem like it should be a problem. Disk queue depth, never waiting to read or write. So that's pretty good. And then if we look at network throughput, doesn't look 250 kilobytes per minute does not seem like it's going to be causing us any issues. So we know it's not the database, right? So what could it be? Well, what you can do is you can actually set up a tool called htop. Well, there's top and there's htop, and you can look at that at the process level. So that's what I've done here. So let me quit out of it. You just basically htop, that's all you do to run it. And it brings and gives you a process list and tells you, what's consuming the CPU. So right now, you can see there's a ton of incoming requests, it looks like, right? It looks like this is a bunch of web requests coming in, and that's really what's driving the CPU. There's just so many of them. And that's why the CPU is spiking. So we have a lot of traffic hitting our website. So what I was looking here for is there's no rogue process. So there's nothing running weird here. It's just looks like a lot of traffic, a lot of valid traffic. So what we're going to need to do is figure out how we can adapt our infrastructure to handle the amount of web traffic that we have. And that's what we're going to look at through two different approaches, right? We're going to talk about horizontal scaling and vertical scaling. And we'll actually start with vertical scaling. So what do I mean by vertical scaling? Vertical scaling is this idea of just using a bigger instance, essentially, right? So the instance we were using previously had one virtual CPU. We know that the traffic is operating sort of in that 60-70% range, and it should be in the 20% range. So we know we're between a factor of 3 or 4x off, right? We need about 3 to 4 times as much capacity as we have. So we're going to try a 4 vCPU machine. And what I'm going to do is I'm going to use that Apache benchmark tool that I mentioned before, and I'm going to simulate the load that I'm seeing on my current server on this server to see how it handles it. So I looked at my system, and then I tweaked Apache benchmark until it was kind of producing the same number of connections and the same amount of load on a single CPU system. And then I'm going to run that on my 4 CPU system. So that's what we're going to look at next. So as I mentioned before, we have to simulate the load. So what we did is what I did is I went and I said, okay, on my 1 vCPU machine, it's operating at about 60-ish percent, 70-ish percent CPU, and I looked at it and said, okay, that represents traffic from about 64 connections. So what I did is I used this tool called Apache Benchmark, and I simulated the production load that I was getting on my single vCPU machine and came up with the right number of concurrent connections. So in this case, it's 64, which you can see right here, connection 64. And so what I'm going to do is I'm going to use Apache Benchmark to then hit my servers that I'm testing out. So I'm going to test out a 4 vCPU server right now, and then we're going to test out a load balanced collection of 3 servers, and we're going to see how they handle the load. So this command AB Apache Benchmark, what it's going to do when I start it is it's basically just going to send traffic to that SA4 machine, SA standalone 4 vCPU machine. And so that's what I'm doing here with Apache Benchmark. And I just wanted to show you real quick how I get that going. And then we'll go ahead and look at how that performs using a tool called HTOP. And then we'll see how it looks in the metrics graph. So let's go ahead and take a look at the metrics graph now. Okay, so here is the first thing we're looking at. This is the graph for our 4 vCPU instance. So if we come down, we can see obviously that it's handling the load really well, like we'd expect it to, right here in the 20%, kind of the sweet spot. I've set up a tool called HTOP, which I mentioned earlier, to monitor it. And so here you can see these are the 4 vCPUs. I just bring this up because when we do a multi-CPU graph using the Lightsail metrics page, you just see an average load across all 4 CPUs. So if you wanted to actually kind of see how it was breaking down by CPU, that's something HTOP will show you. So you can see it bouncing here between 26, 22, 19, kind of in here and bouncing up. But on average, over time, the CPU is staying well below 20%. So this is obviously one way to scale the load up. We've gone from 1 virtual CPU to 4 virtual CPUs, and we're handling the load quite effectively. So that was the vertical scaling. Let's talk about horizontally scaling or horizontal scaling. That's when instead of getting a bigger server, you just get more servers, right? And because our web front end is stateless, meaning there's no information on any particular server that makes it unique, I've taken all of the data from my application and moved it into my database, right? I can replicate those servers as much as I need because they're all basically kind of these stateless machines that don't really have any individual, personality, if you will. You may have heard the phrase "pets, not cattle," right? Or "cattle, not pets." Whereas this idea of these are just a fleet of machines. They're not treated in any special way. You can replace them and move them in and out as you need. So the way we're going to do this is we're going to use a Lightsail load balancer, and behind that load balancer, I have replicated my front end server And it's the same instance type. It's that same one that we were using in the standalone with one vCPU. So it's a standalone one vCPU server. Now I have 3 of them, and they're all connecting back to the Lightsail database. So we're going to take a look and see how that approach handles the traffic, and then we'll talk about some of the pros and cons between the 3 approaches and which one you might choose. So let's go ahead and jump into that now. Now, the other way we mentioned handling the load, right, we just talked about, was how do you handle it when you horizontally scale. So in our case, rather than adding 4 CPUs, we added 3 instances with 1 CPU each and put them behind a load balancer. So let me actually real quick go back over here to networking, and just so you can see where that's at. Here's that load balancer, and here's my 3 instances, FE1, FE2, FE3. So if I come back and I go into FE1 and I look at the metrics, you can see that, yeah, there was a spike here for whatever reason. Maybe there's a big chunk of load right there, but for the most part, it's staying well underneath the sustainable zone. And you can see that on each of these individual graphs. So this is the graph for, let me close this, for FE2 right here. And then if we come over and we say, here's the graph for FE3, and we can refresh it. And here's the graph for FE3. So again, like you saw with the 4 vCPU graph, we've been able to take the load and instead of putting it on 4 different CPUs on the same machine, we put it on 3 CPUs across 3 different machines, and they're all handling the load quite well. So like I did before, I've got top running over here on these 3 machines, and you can kind of see here's CPU at 8%, 2%. They're jumping up to 27, 26. So you can see them kind of, if you watch the graph for a little while, the load come and go into each of the individual different machines. So that's the load balancer routing the traffic across those machines. So let's go back to the slides, and we'll kind of do a recap on what we just saw. So let's look at the 3 scenarios that we had, like the base scenario, which was a single vCPU instance, and that instance costs $10 a month. There's also a cost for the database, of course, but we're just looking at the cost of the instance. So $10 a month for that instance, it didn't handle the performance. It was non-performant. Couldn't live with it, didn't have enough CPU power. And it wasn't highly available. We didn't really talk about this, but in both scenarios 1 and scenarios 2, there's 1 server running there for the web tier. And if that server was to crash, the whole site would go down because there's no redundancy at all. So, that is an issue not related to performance, but availability and scalability, or availability at least. And, if you were going to keep the same architecture, like just 1 machine for your website, your only available option at this point is vertical scaling. So if you don't want to add more servers, right, if you don't want to go with a load balanced approach, your only way of dealing with performance is always going to be just to buy bigger machines, which is what we did in the second option, right? So that 4 vCPU machine is $80 a month. And one of the things that we didn't really highlight is that it's not just that you're getting more CPU, you're getting more RAM, and you're getting more disk space, and you're getting more data throughput. But really, none of those things were a problem for us, right? We don't need more RAM, we don't need more disk space, we don't need more throughput, but we're going to pay for them anyway. So when you say, well, I'm going to vertical scale, on Lightsail, that means you go to the larger bundle, which means everything gets bigger. RAM, data transfer, and disk space. And you may not necessarily need all of that. So you're going to be paying for capabilities that you don't really want. So this performs really well, but it's still not highly available. And again, if you don't want to change the architecture, if you've got 1 bundle bigger than this, and that is $160 a month, and that would get you to 8 vCPUs. So again, you'd be paying a lot of money for resources you're not using in the terms of RAM and disk and data transfer. So probably not the best option. So then if you go to the last thing we looked at, the load balanced approach, that ended up costing you $48 a month, plus the database. And apparently I dropped the E on database on that there, but it's database. And that's because you're using 3 instances and they're $10 each. So $30 for your instances, and then your load balancer costs you $18 a month. So you go from $10 to $48, which is non-trivial. It's almost a 5 times increase, but you get high performance and you're highly available now. So assuming that you did a Lightsail highly available database, you'd have a highly available front end and a highly available database. If you didn't do a highly available database, it's not a ton of work to migrate to a highly available database. So you could then move your database to highly available, load balance your front end, and you can do that. Now, if you actually want to go through that process to build an application like that, I will mention this. You can go to a website, scale.lightsailworkshop.com, scale.lightsailworkshop.com, and that will allow you to go through the whole process of how you set up the load balancer, how you set up the database, how you set up the web front end. And you'll end up, if you've never built a load balanced application before, that'll walk you through how to do it. So scale.lightsailworkshop.com, scale.lightsailworkshop.com. I think I may have left a dot out on the previous one. So anyway, scale.lightsailworkshop.com, just to say it like for the 8th time. Okay, so those are the approaches. Obviously, I think it's pretty clear that the best approach is actually not vertical scaling in this case, but horizontal scaling, since really all you're trying to do is get more CPU on the problem. So you get more CPU on the problem, you get the benefit of having a highly available web front end, and you have the option now to vertically scale and horizontally scale if performance demands it. So let's say you get in a situation where you've load balanced it, and 6 months down the road, you're now seeing that you're running out of memory. Okay, well now I can vertically scale all of those instances. So I'll go from the 1 vCPU machine maybe to the 2 vCPU machine that costs $20 a month but has more RAM to accommodate that, right? So horizontal or vertical scaling, whichever meets your needs at that point. So to wrap it up, final slide, we looked at, a pretty solid getting started use case, right? If you're not doing any monitoring today, if you're not doing any alerting and notification, this is a really good place to start using the built-in functionality that is already in Lightsail. But if you needed, for instance, greater granularity on your monitoring, so we give you free 5-minute monitoring, but you wanted to monitor every minute, or if you wanted some advanced metrics. So there are no metrics for monitoring memory usage, for instance, with Lightsail right now. If you wanted to do that, you'd want to move to CloudWatch, and that's great. CloudWatch allows you to monitor at a more granular level, to set up more custom metrics, and really be able to do a very comprehensive job of monitoring your system. It also gives you logging, the ability to centralize your logs and move them off of the individual instances into the AWS console. So those two things are great. It's a little more advanced though, right? You're gonna need to install an agent on each of your machines. You need to set up IAM permissions. We talked a little bit about IAM in the beginning, identity and access management. So it's not impossible. It's not actually really even all that hard. It's just additional work that you'll need to do, and you'll be working in Lightsail and then in the AWS console to deal with CloudWatch. So your metrics won't be in the AWS console anymore. Well, they will be the 5-minute ones, but the ones you're looking for, the 1-minute ones, the additional custom metrics, they're all going to end up in CloudWatch, and so you're gonna have to leave Lightsail to look at them. Whether or not that makes sense to you completely depends on your use case and the things you're trying to accomplish. But I just wanted to let you know that Lightsail is a great way to get started, and many of you will probably use Lightsail, and you'll set up the monitoring, alerting, and it'll work fine for you for as long as you run your workloads on AWS. But if you run into a situation where you want to do some advanced monitoring, there's a way to do it, so that's that. So with that, I wanted to save a few minutes at the end for questions, which we've got a few minutes here to do. Put your questions in the Q&A dialogue, and we will respond to them. So let's check for those questions now.